Did you know the diameter of a strand of hair can be measured by a laser? Curious? Now I'm going to show you how it's done. Tape the hair in the center like that, make sure it's taut. Attach a stand like the one shown here. Next, you will need the wavelength of the laser, which will be stated on it itself, crucial to the equation. Then, measure the distance of the hair to the wall, where the pattern is. Use a ruler and align it with the horizontal line on the wall. And measure the length in between the center and the first dark spot. Now you have all the values to substitute into the equation below, and from there you can find the diameter of the hair. But wait, how is this possible and why? It is due to concepts such as diffraction and interference. It is defined as the bending of waves, be it sound, light or electromagnetic waves, around the edges of an object, and the difference between the size of the wavelength of the wave and the size of the object opening determines the amount of bending of light. Actually, it happens with all objects, but because the object is much larger than the light's wavelength, the bending is almost unnoticeable. However, if the two are closer in size, such as the hair and the laser, the amount of bending is considerable and can be seen. An example is the silver lining among clouds caused by light bending around their edges. The process in which two or more waves of the same frequency and wavelength combine to reinforce or cancel each other, the amplitude of a resultant wave being higher, lower, or the same amplitude. It occurs when two waves of the same wavelength have their crest or throws both aligned, resulting in a wave of a higher amplitude. It occurs when two waves not perfectly aligned interact, resulting in a wave with shorter amplitude than the original. This is because when the two waves are not perfectly aligned, a throw of one wave will pull down the crest of another, leading to the shorter amplitude. Examples include the rainbow hues seen in bubbles and the rainbow pattern seen in spilt oil on concrete. Now that we have defined the concepts, here is the explanation of the results. The light from the laser travels in a straight line until it reaches a strand of hair, where it diffracts, making two sources that are close to each other. After passing the hair, the light rays travel different distances before reaching the wall. The pattern of alternating bright and dark spots occurs because of constructive and destructive interference. When waves interact constructively, the amplitude formed is higher than before. When they interact destructively and are shifted by exactly half a wavelength, the crests and throws perfectly overlap and effectively cancel each other. A series of constructive and destructive interferences forms a diffraction pattern on the wall. Anyway, back to the equation, where it is supposed to give you the diameter of the strand of hair. Lambda is the wavelength of laser, d is the diameter of the hair, and sin theta is the distance of the middle of the first bright spot to the first dark spot over the distance of the laser from the wall. The method is an effective estimation of the diameter of narrow objects such as hair, wire, or needles. It's been a long one. That's all I have for you today. I hope you enjoyed this video and found it informative. Thanks for watching.